Alright, so example 3, it says find where h of x is equal to x to the fourth minus 4x cubed. It's increasing and decreasing, and then we just need to use the first derivative test to determine any local extrema. So critical points does involve me finding the derivative, so I'm going to find h primed of x. Sorry, I really don't like highlighter. So then I would get then 4x cubed minus 12x squared, and then I would set that equal to 0. So I've got 0 is equal to 4x cubed minus 12x squared. Factor out my GCF, which should just be 4x squared times that x minus 3, which tells me that my critical points are going to be at x equals 0 and at x equals 3, setting each one of those factors equal to 0 like we did since Algebra 1. Alright, and then I just make a sign chart because sign charts are great. And then I just plug numbers in before 0. She gave me a positive and a negative. In between 0, so if I plugged in 1, for example, that's still going to give me a positive and a negative here. And then plugging in after 3 should give me a positive times a positive, so overall that's going to be positive. Alright. So you might have had a graph that looks something like that as far as that negative slope goes. So there might be a little quote-unquote hiccup in the graph, as I sometimes call it, but that's about it. That's how you can stay decreasing and decreasing and still have, you know, an important critical point there, which we'll talk more about here in a little bit. So what this means is that we are decreasing on negative infinity to 0 and 0 to 3 on with h. And then h is increasing from 3 to infinity. Alright, so the big question is, do I actually care if it stayed decreasing? No. I only care if there's going to be a maximum or minimum if f prime changes sign from either positive to negative or negative to positive. So where does that happen? Well, that happens at x equals 3. That's where it goes from being negative to positive. So at x equals 3, h prime changes from negative to positive. Therefore, which again is a little bowling ball looking symbol, usually without the parentheticals, but it's just the 3 dots. Therefore, there is a relative minimum at x equals 3. Alright, and cleaning that up slightly. Again, explanations in calculus are worth a lot of points. Sign charts aren't worth anything, but they are extremely helpful and they are still valuable. So even though they're not worth any points necessarily on free response questions, I would still definitely write them out and draw them. Yeah. Example 4 is just that same deal. We need to find the function g of x, where x squared times e to the x is increasing and decreasing, and then we need to find any local extreme. So first things first, let's find the derivative. So I know that my product rule is going to apply here. So I see that u is equal to x squared, and v is going to equal that e to the x. So then u primed or du should be equal to 2x. And then v primed or dv should be e to the x times derivative of x, which would just be 1. So guess what? The derivative of e to the x is just e to the x. Alright, and then using that product rule, I should know that g primed is just going to be u, which is x squared times e to the x, because that's v primed, and then plus u primed, which is 2x, times v, which is e to the x. Alright, and then I see that I've got a GCF of e to the x, And I also see that they both have at least one x, so I'm going to go ahead and factor that out. So then I would get my derivative is going to be equal to 0 at a critical point anyway, so I'm just going to go ahead and say that's equal to 0. Factoring out that GCF of e to the x times x should leave me with just, what, x plus 2? So therefore, my critical values are just going to be at x equals 0 and x equals negative 2. Because honestly, e to the x, it never crosses the x-axis. If you guys remember, that e function just ends up looking something like that, where it's got a horizontal asymptote at 0, so it's never actually going to cross that asymptote, which is kind of nice. So we really don't have to worry about it. It's kind of like, less work for us. Cool beans. Alright, so then I'm going to go ahead and make my sign chart. Alright, so I've got 0, I've got negative 2. Alright, so then I should get number for negative 2. For example, negative 3 should give me a negative and a negative, so overall that should be positive. In between negative 2 and 0, plugging in negative 1, for example, should give me a negative and a positive, which overall is going to be a negative. And then 0 is my other critical values. I need to plug in a number above 0, which will give me a positive and a positive. Again, that e to the x is always going to be positive, so if you want to include that on your sign chart, you can, but if it's always positive, it's not really going to affect anything. Alright, so what that tells me is that h is increasing on negative infinity to negative 2, ending with 0 to infinity, and h is decreasing between negative 2 and 0. Alright, but it's asking me to find the extrema. So I also need to figure out, okay, where does it change from being positive to negative, if anywhere? Well, positive to negative, I see that that's at negative 2. So since G changed, since G prime changed from positive to negative at x equals, then there's a relative max. Alright, and then since G primed changed from negative to positive at 0, there's a relative min. Alright. Okay, again, explanations, all of it. Please write it out. Let the readers know that you guys know what the heck you're talking about. Get your points, okay? They're gonna be silly little points, but they're gonna want to see everything written out. Explain it to them like they're learning it for the first time.